Very good morning, channel viewers. Myself, Dr. M. H. Channaya, and in today's session, we are going to study the development of a right circular cone which is cut by a section plane which is perpendicular to both HP and VP. So, friends, basically in this problem, we have to place this solid on HP on its base, get the top and front views of the cone to start with. So friends, we will get for the cone a circle in the top view and a triangle in the front view. So friends, let me mark the base, that is a circle having diameter equal to 50 mm. So I will just mark it as 50 mm or 550. 5 indicates a diameter. So this is a circle in the top view having diameter equal to 50 mm. And you all know very well, the cone has no edges or corners, and hence we have to divide the circle, the base of the cone, into 8 equal parts. I have divided into 2 equal parts now by drawing a vertical and horizontal line. I draw another line here at an angle of 45 degrees. So again another line perpendicular to that, which will lead to the division of this into 8 equal parts. Friends, here let me mark this as A, B, C, D, E, this is F, this is G, and this is H. So friends, corresponding to this top view, we'll write down what is the front view. I told you front view is going to be a triangle. So I'll just mark these corners, that is A dash, this is E dash, by drawing verticals from here. This is point E dash. Center you have got C dash and G dash. So here I will write a vertical line through O, the apex, join that to this. But before joining that, in the question if you see, they have given the diameter of the base and the length of the slant generator or the generator in general. So instead of giving the height, it has been given the length of the generator. Friends, if you see this generator OE, it is parallel to VP. So I've got a point on that. Now with this as center and radius equal to the slant generator length or generator length, you can strike an arc to cut the vertical line drawn through this point O1 dash at O. O represents or O dash represents the front view of the apex. So let us join O dash to E dash, O dash to A dash, and here friend, this length whatever I have got here is R, that is given directly as how much, 100 millimeter. So that becomes a true length. So we can also just mark here as 100 mm. This is also equal to the true length of the generator. And friends, from all these points B, D, etc., we will draw vertical lines to obtain the divisions in the front view. So friends, I will join these points by a line here, another line here. Friends, this point will be B and H. This is GC. We will call it as G dash, C dash. This is F and D. D dash, F dash. This is B and H. So there's no L mark it here. B dash, and this is H. It has to be marked above, but since there's no space here, I just mark it below. Friends, in case they ask you to find out what is the height of this cone, you can simply measure this vertical height. That will give you the height of the cone when the length of this generator is 100 mm. So we have completed the first part of the question, that is drawing the top and front views of the cone. Now friends, let us move on to the development part of it. So before the development, you have to see how the solid is being cut. Here friends, it is cut by a section plane in this position, by a section plane which is perpendicular to both HP and VP. So friends, whenever the section plane is perpendicular to both HP and VP like this, it is seen as a line in the front view and also as a line in the top view. And he has specified it is at a distance of 10 millimeter from the axis. Axis is O dash, O1 dash. So I am going to write a line parallel to the axis, that is a section plane. This section plane is at a distance of 10 millimeter from the axis. This is given as 10 mm. So this is the section plane SS, which is perpendicular to both HP and VP. And friends, here after the section plane cuts the solid, we are going to retain generally the larger part of the cone, but it is also specified, draw the development of the lateral surface of the larger part of the cone. So larger part is this part, and this part is retained for the purpose of drawing the development. So friends, if you see the points where the section plane is cutting, it is cutting slant edge O dash A dash here, the slant edges, generator O dash A dash, generators OB and OH here, 1 point, 2 points here, and it is cutting the base because this line A dash on XY represent the base, so it is going to cut here and also at this point. So basically there are 2 points here, 2 points here, 1 point here. So there are totally, you are going to get 5 points in the development. So now let us move on to the second part to draw the development of the larger part. We will call this part as P. P is the larger part for which you are going to draw the development. Friends, before drawing the development, we need to have the subtended angle or the sector angle, which is given by the formula theta is equal to small r by r into 360 degrees, where the small r is the radius of the base or the diameter by 2, that is diameter by 2, diameter is 50 by 2, that is equal to 25 millimeter, and this capital R is the length of generator, and this length of generator is given in this question. Generally it will not be given, they will give you the height, but only to have a small change I have given the question in this form. Friends, substitute in the formula, you get theta is equal to 25 by 100 multiplied by this 360, and that works out to 25, 1s are 25, 4s are, that is 90 degrees. So 90 degrees is the angle subtended at the center. So let us draw the development now. Friends, here for all the developments we need the true lengths only, whether it is a pyramid, a cone, a cube, or a prism, whatever it may be. So I am going to mark here a line of length is equal to O dash E dash, that is R, which is equal to 100 in this problem. Remember friend, this is the true length. So whatever the length you have got, that is 100, I just marked here. And the angle we have calculated right now, and that has worked out to 90 degree. That is, let's say here, theta is equal to 90 degree. Now friends, with O dash center, 100 millimeter radius, I am going to draw an arc. So this arc is drawn. using center O dash, radius is equal to 100, and then this is also going to become equal to 100. Friends, now this angle theta is to be divided into the same number of parts as that of the base. So base has got 8 points. So we have to divide this into 8 equal parts. So friends, do you like this? This is divided into 2 parts. Then it has become 4 parts now. Again 2 more. One here, one here, one here, and one here. So totally friends, we have got 4 into 8 divisions. We have divided that angle into 8 parts. So now friends, we have to see from which point on the base the development is to be started, or from which generator it has to be started. If you look at the front view, a part of this O dash A dash is removed and the remaining part is existing. So you can start the development from any point of your choice. So let me say I am starting from A. This is B, C, D, E, F, G, H, and A again. The starting and ending generator should have the same numbering. Friends, now let us start with the points where the section plane is cutting the generators and the base. The generator O dash A dash is cut here. O dash A dash is the true length. Now I take this measurement on O dash A dash in the development and mark that. Say friends, I am getting a point here, another point at the same distance. So this is where the section plane is cutting. So similarly, these generators OB and OH are O dash B dash and O dash A dash are cut here. But these two are not true length. You can shift it to the true length last generator or this O dash A dash and take this measurement on OB and OH. So you are going to have this measurement on OB and OH below. OB and OH. OB and OH. Friends, you have got this point. You have obtained this point also. Finally, let us come to the base. The base is cut here on GH and also on this is BC, almost at equal distance. That is, the distance of this from here is the same. So we will mark this point B and H, because here for small values of this theta or this angle, the length is equal to that arc length. So friends, we will mark on GH this point, on GH. We say okay, a point here. Similarly on BC, we have got at the same distance BC. Friends, we have got totally 1, 2, 3, 4 and 5. And whatever the points you have got now, please join them by a curve, a smooth curve. So friends, I am going to join these by a smooth curve again here by a smooth curve, and this part is retained, the larger part, darken that, and finally friends, all these generators above this are available, that is on OA. This part is retained, so I am going to join this and again on this. Friends, this is how the development looks when the larger part of the cone is developed. Friends, I'll just mark it as the development of the. Hope the presentation was interesting, and if you like this video, do share with all your friends. Thank you.